Today we're going to investigate digestion, and in particular we're going to look at digestion in the mouth. Remember to pause at any slide, particularly with the worksheets if you need to read for more details. We're going to look at 3 macronutrients, proteins, lipids, the fats and carbohydrates, and we're going to look in the mouth where the teeth do the mechanical breakdown, saliva provides enzymes, dissolves the food for taste, acts as a lubricant, and the tongue helps move the food and assist swallowing. And the saliva contains an enzyme, amylase, which starts the chemical breakdown of food, requiring a pH of very close to neutral, only working on carbohydrates. And so all of the 3 macronutrients are broken down by mechanical means in the mouth. Teeth are chisel-shaped in sizes for biting, canines, sharp for gripping, perhaps more important in wild carnivores, molars and premolars, which are flat for crushing and grinding. And the surface of the tongue has taste buds. It's a myth that there are particular regions, but they do detect 5 tastes: bitter, sweet, salty, sour, and the umami savory taste. And if you want to see a rotating image of amylase, go to amylase Kenya. And so bread is a carbohydrate made up of a polymer, which is starch. The hexagons below are the repeating units, and the red links are what needs to be broken during digestion. And so saliva is going to act on starch and start the digestion of the polymer starch molecule. The enzyme amylase is going to break down not every link here, but most of them, because we want to end up eventually in digestion with glucose. And so salivary amylase activity and your safety, keep the saliva inside the beaker, dispose of very carefully with bleach, and clean your lab bench well. And here are the materials that you will use. We're going to use saltine crackers and iodine solution for testing. So you're going to put about 1 centimetre depth of water in one of the beakers and carefully spit into the second to get about 1/2 to 1 centimetre depth of saliva. Crumble half a saltine cracker well in each of the beakers, and you'll add 3 drops of iodine solution to each beaker. Leave for 3 minutes, but note the appearance thoroughly before, during, and after. The iodine test, the starch polymer will trap iodine within the starch molecule, resulting in a material that is dark blue or blue-black. In the absence of starch, the iodine will remain brown, and you can see it in the dropper at the top here. And here's a sample where it's been added to the saltine cracker. The colour there is the blue-black. 2 beakers with the crushed saltine crackers. Predict what's going to happen in both beakers. The saliva on the left, the water on the right. And we're just going to look at a video of the activity.
Down carbohydrates, turning it into maltose, and then after a while it'll start to be soft. The bolus.
Okay. Okay. So I heard salivary glands, I heard bolus, I heard maltose and glucose. I don't believe that we got from the saltine cracker to the bolus quite well enough. Well, I don't know who was first. I think I saw Electra's first. It might have been Henry though. I saw yours about the same time. So Henry, go ahead.
So your teeth and tongue are part of the mechanical digestion, which help mash up the saltine cracker, which then the amylase from the enzymes in the salivary glands can help break down into the maltose and glucose, and then it's turned into bolus, which then gets you swallowed down your stomach.
Great.
Saltine cracker is one of those things you put in soup, right?
What?
Yes.
I thought it was soup. Well, they have them down there right next to the soup box, I think. That's a saltine cracker.
These are lab supplies. These are not foods.
No, Bill, they're literally just like
They're normal saltines that once I bought them.
They're radioactive.
Once I bought them in the grocery store and brought them into my lab, they became lab supplies and not saltines. So, what we're going to do is we're going to do a test. This test can be found on page 3, I believe, of your unit packet. In order to do this test, I need everybody's help.
Starch.
Carbohydrate is the macronutrients. Starch is the polymer unit of the macronutrients carbohydrate. All right, so the carbohydrate and starch, we use those words interchangeably in 8th grade, and that's okay. I need a tissue. If I put iodine on starch, do you know what happens?
It turns blue.
It turns blue.
Oh yeah, that's true.
It says it right here.
Ah, yeah. I was like,
I was out camping, and I had iodine water.
I was really impressed.
Also,
All right.
And I washed my bowl that had oatmeal in it.
So,
And it turned blue.
do you guys want to come closer?
I like blue crackers.
Iodine in these, like,
no. That's not.
Yeah, you can put iodine on.
no, I can put it in water to make it
Okay,
different.
this is officially a dark blue.
Oh yeah, it is.
Okay,
Oh, that's brown.
No,
It looks-
exactly on the cracker.
the one that's on the cracker, it's officially a dark blue. So, what I've done is I've filled this bottle up with water. I want to see if the water digests the cracker. So, I'm going to use mechanical digestion in my hands. I'm going to break it down into little bits. In this bowl, and so it's going to dissolve a little bit into the water, and we're going to see, I'm going to put some iodine in there to see if it has digested.
Is iodine acid or?
If it turns blue, that means it has not digested. There are still a lot of starch.
Oh, is
In this one, I'm going to put amylase.
Oh,
Also known
Does
as.
anybody have amylase that I can put in here?
I got this in my
Alright?
no.
Now, I need to borrow your amylase. Okay, I'm serious, totally serious. For this lab to work,
Bill.
watch carefully the demonstration. Okay? Watch carefully the demonstration. No loogies. Did you hear that? No loogies. And I don't out all over the place. I
Oh.
drop it carefully.
That's disgusting.
Next,
No.
I need all, in order for this to work, I need all of your amylase. Alright? Gabriel,
This is like your blood
I'm serious.
donations.
okay? So,
Absolutely not.
please do not
And it's Olivier.
spray all over.
No.
Alright? Next. Alright, did you guys hear the noise?
Everywhere.
That's the noise that I
Okay, I'll do it after you.
don't. Alright, so right now, you guys think of pizza, think of garlic, think of,
That was so chunky. Yeah, I know. I've been preparing it for a while. I prefer
yes.
I prefer to go.
Chunky piece of pizza.
It's not good.
Wait, actually? For real? For real? Yes. Oh, Bill.
Like,
Alright, so
9th grade, 10th grade, and 11th grade.
I'm doing mechanical digestion, and I'm putting in the saltine into this. I'm trying to make it as fine as possible, just like your teeth do. As fine as possible, just like your teeth do. Now, in order
If it's
for
okay, don't cry.
the magic of chemistry to work, we have to wait a few minutes. Why? Why do we have to wait a few minutes?
So that you can let
Digestion immediately.
What's okay? So first of all, why did I have to break it into little bits?
because that's what makes it.
Bill.
Not because that's what my teeth
Bill,
do.
you don't
Why do
see
my
who
teeth
has to
do
break
it?
it.
I'm gonna call Henry this time because you guys both had your hand up at the same time. So Henry.
Because
Like I've never seen so much sleep.
Okay, tell me more about that. William Focus, he had a really good answer.
So chemical digestion, like if it's broken up, then the chemicals can get all around the different food particles, and that helps to speed it up. If
Great.
you just put a big chunk of saltine cracker in there, it would take like hours, if not days.
Yeah, because it would just do the carbohydrates on the outside and then have to work very slowly inside as it digests. All right, great. Now this is also, we'll get to that later. I'm going to focus on the pretty blue color.
Indigo.
This is a dark blue,
That's dark blue.
officially a dark blue. Shine into the one with water.
Like green. It's
And you see,
It's blue.
it's green probably because the yellow table that's underneath it. Let me move it to,
Oh, that's blue.
yeah.
Oh, yeah, that's
So you got the blue black or purple, whatever you want to call it.
bruise.
And so let me put this one on the white background as well.
if it is digested.
Well, let's find out, won't we? And
Same color.
Oh, it's digested. Yeah, Rob, same color. It's digested.
Yeah, Rob, same color.
so it stays that same color. You see that there's little bits of blue-black in this one
Yeah.
because we didn't fully wait long enough for the entire cracker to get digested. So it did find some starch, but in general, it found digested bits.
And here are the results. Which one confirms that starch is present? Blue-black colour. And any blue-black colour in the left one, the fragment of saltine may have been a little bit large. Then pause as you go through these if you want to with the Cracker Lab and see some of the student additions here. And then we're going to explain what is happening, and we're looking at digestion in the mouth. We're breaking the long starch polymer molecule up with enzyme action. And then the glucose will be small enough to be absorbed in the small intestine. So what happens to the other macronutrients? And this is not just in the mouth. Digestion of proteins, they'll be made smaller with the teeth in the mouth. And then the long protein molecule, which is the polymer, will be broken up into those individual amino acid units with the enzymes pepsin in the stomach and then trypsin as well. The pepsin, remember, in the stomach works with a low acid pH with the hydrochloric acid in the stomach. And the trypsin comes from the pancreas, and you get molecules that are small enough to be absorbed in the small intestine. Now lipids, fats, they're going to be emulsified, and a large globule clump of fat needs to be broken down mechanically by emulsifiers from the bile salts into these smaller flat globules, but then it needs another enzyme, lipase, in the small intestine to break the food molecule down. And then this breaks it down into a form that is small enough to be absorbed in the small intestine. So once they're in the small intestine broken down, they're going to be absorbed because the small intestine has a very enlarged surface area with these finger-like villi to maximize the amount that is absorbed. And then again, pause these, a reminder of class notes. And then solidify your knowledge. Answer these questions. What happens to the macronutrients, carbohydrates, fats, and proteins in order for them to be absorbed in the small intestine? So pause that and do some answering. And very many thanks to WIS Science and Mr. Marsh at Washington International School for lab facilities and the students doing the lab.